Hi, Miss Morris here. It's time for some more math fun. I thought I'd try and put a video together to review Pythagorean Theorem and special right triangles. You will need to learn to distinguish when to use Pythagorean Theorem, which is a squared plus b squared equals c squared, versus the shortcuts of special right triangles. And you'll be seeing problems. Like some of those I've shown you just now. Both of these problems would be Pythagorean Theorem as the best way to work them. You're given lengths of 2 of the 3 sides of a right triangle in each picture. In class we discussed you must first find C, the longest side, and it is always across from the largest angle, which is the right angle. So this would be the side C, and again this would be side C for this problem with respect to the equation. We talked about Pythagorean triples, 3 numbers that when applied to Pythagorean theorem are all whole numbers that work perfectly, and I gave you a rhyme to memorize, and right here this is one of them, 6, 8, 10. So I'd be done with that because I learned my rhyme. And it's super important that you do too. It's in your notes. Let's work this one and see if we can remember anything about it. This would be side C. So either of these can be A or B. So we're going to say 5 squared plus 12 squared equals C squared. That gives us 25 plus 144 equals C squared. As a review on the calculator, I could go 5 squared, so you can see all this, plus 12 squared, hit enter, and right there you can see it's 169. That gives us C squared, but we don't want C squared, so we take the square root on both sides, and we get, here in the calculator, I'm going to hit Control, square root, Control, by hitting my negative sign, I'm going to pull up my last answer, hit enter, and it says it's 13. Therefore on this one, C equals 13. What do you know? That was a Pythagorean theorem triple too, or Pythagorean triple. 5, 12, 13. This is 6, 8, 10. To prove this one, 6 squared plus 8 squared equals 10 squared. 36 plus 64 equals 100. Yes, indeed, 100 equals 100. Both use whole numbers, fit the theorem, so they are both Pythagorean triples. See your notes for the other 2 I listed, and any multiple of any of the 4 listed will always be a Pythagorean triple. I just repositioned this so you could see it. I just repositioned this so you could see the whole thing.